So we left it in the previous video saying there are different types of El Niños. We have already mentioned it. So these are now discussed a lot. These are called flavors of El Niño, diversity of El Niños. And of course, the question is how exactly are they different? And if the fundamental process of recharge discharge are somehow changing when these different flavors of El Nino happen. And there are already papers arguing that the pathways with which the warm water accumulates in the tropical Pacific is in fact different for the different types of El Ninos, and whether the El Ninos of one flavor are happening in one decade and another flavor in another decade, and what would drive such a decadal change in the flavors of El Nino. All these are difficult questions. Lots of papers. If you read all of them, you will still end up leaving with the sense that we don't exactly know what's happening. So it's okay. That's how science progresses. So this is a nice paper that I cite somewhere that you can look up. Differences in the onset of El Nino events. So we said onset starts with discharge, but when we say onset of El Nino, we're talking about the surface expression. So between 1950 and 1976, the El Ninos typically evolved from the east on the coast, Nino 1+2, and extended towards the dateline. The Rasmussen and Carpenter paper became quite popular, famous, canonical, did the composite analysis for El Ninos before paper came out in 82, so they had looked at El Ninos before and made a beautiful story about the onset, the growth, the mature phase, decay phase, etc. And boom, 82, 83 came and it evolved quite differently, and we learned very quickly that El Niños evolve very differently. So between 1976 and 96, they seem to have evolved this way, where you had this extratropical connection, which some of you may know as the Pacific meridional mode. So there is a seasonal footprinting mechanism. So of extratropical SST anomalies induce tropical responses in terms of winds, and they persist across seasons. And if you perturb things here and produce a wind anomaly, you set off the waves that we just talked about, and the waves can set off thermocline movement, positive feedback, coupled feedbacks, and El Nino, and so on. But you can see that the cold temperatures remain here, and the warming tends to be focused around the dateline, which is why they are called dateline El Ninos or Central Pacific El Ninos, and so on. The 97-98 El Nino seemed to be quite complicated. It also evolved from here, also warmed over here, so you can see that maybe it was combining, and we don't know the impact of the warming in the background state. During all this time, global warming is happening and the East Pacific is not warming as fast, or maybe even cooling, and West Pacific is warming fast, so background sea surface temperature gradients, pressure gradients are different, and so on. So arguments obviously ended up being made that when we looked at the El Nino since, the frequency of the so-called Central Pacific El Ninos have in fact increased. Is that really true? Always comes down to having a number of samples that is large enough to claim such a thing, but unfortunately we don't have a large number of El Ninos to worry about these. So we can just move on to the Nino 3.4 index again, also known as ONI, Oceanic Nino Index, or whatever. So you can see La Niñas, multiple years. El Niños typically don't occur together for more than 1 year, but there are exceptions. We mentioned the period of this is 1970s and the 1990s. This was a very special period which immediately produced a paper claiming that this was related to global warming, but now we are back to looking normal, especially when you consider 2015, 16, and 2020. 23, 24, and 26, 27, that's just evolving. Okay, so are the models able to reproduce such episodic events? Is there really a clustering of El Niños? Are there more La Niñas and more El Niños in different periods? Are there, changes in the appearance or duration or intensity or anything like that, location and so on? All these questions remain open, and people keep on writing papers saying this is happening and that's happening, and what will happen in the future and so on. And people also claim that we are now in a new regime, where the old regime, Eastern Pacific El Nino, used to look like this, warming around the coast extending towards the dateline, but now we are having focused warming around the dateline and less warming or even cooling over here, as we saw in some of these cases. But obviously we don't have enough samples, plus the exact reason why this would happen under global warming is not clear, even though this paper by Ye et al. In 2009 said there were changes in the thermocline, which is obviously being debated again. The main point is that if the teleconnections or the remote impacts of different flavors of El Nino are different, then it becomes really important that the models capture these variations in the El Nino surface signature and their teleconnections. If El Nino happened in the middle of the ocean and it didn't affect land, then we may not worry about it. If it affected fish, we would worry about it, which El Nino does, and El Nino affects weather on land and health and crops and floods, droughts, wildfires, displacements of people, etc., etc. So we must worry about it. So the nice paper showed that when you have EP, Central Pacific, or how the differences between them appear, then the impacts on Indian monsoon are supposed to be different, even though again it's a question of number of samples. One nice paper came out in, I think, 2006 or so, that claimed that Central Pacific El Ninos have a bigger impact on the monsoon, and more stronger droughts happen when the warming is around the dateline as opposed to this one. Again, we don't have enough samples, but the US also sees different impacts based on whether you have a moderate El Nino, strong El Nino, and what the differences look like. So very nice paper by Matt Horling. I want to say Matt Horling, no. Anyway, you can look it up. Indian rainfall monsoon is always tricky because you can always look at droughts and floods, and El Nino prediction comes first, and immediately people start talking about droughts in the monsoon, like we did this year, and we did it in 2023 as well. Every El Nino brings this, but yet only about 60 to 80% of the droughts are actually related to El Nino. So monsoon has its own mind, and maybe monsoon, which is a heat source, can do something to an El Nino. We don't know that, even though we know they are interacting with each other. And the monsoon peaks 6 months before El Nino peaks. So, you have to really deconvolve these things and see who is affecting who. But that's not an easy problem to deconvolve, and we haven't done it yet. We will look at a little bit later on that monsoon is also made up of these active and break periods. How is the El Nino affecting the monsoon exactly? Is it affecting through the onset? Is it affecting through active break periods? Is it changing seasonal total or the distribution of rainfall at intraseasonal time scale, and so on and so forth? Many, many questions remain, but let's leave this here and come back and talk about how different El Ninos evolve and what it means. Okay, this one is only about 9 minutes, but it's okay. Just remember, there are flavors of El Nino. Their impacts can be different. Global warming is changing these teleconnections on top of that. So it's a very complicated picture right now. In 2026, oceans are warm everywhere. Land is warm. Middle East is warm. El Nino is happening, and we are focusing on El Nino as if El Nino is in control, but actually it's not. Global warming is superposing on El Nino. El Nino pattern itself looks different in the summer. As we said, West Pacific is warming, so the typical cool SSTs that appear in the west during an El Nino are not always appearing. It is warm all across the tropical Pacific. This will have a different impact on the monsoon and so on. So global warming is very much present and will affect the El Nino itself and El Nino's teleconnections. Okay, we'll come back and continue.